Okay, Assalamualaikum and hi everyone. So we are in the last part for chapter 9, which is parametric differentiation. Okay, so for parametric differentiation, there are two formula that you have to know. So this is one here, this one formula here, and the other one formula here. Okay, so this formula, we are going to use this to find second derivative, and this formula we are going to use to find first derivative. Okay, so basically for parametric differentiation, you have to know two of this formula and also all your basic rules of differentiation. Okay, before that, what is parametric differentiation? So as you can see here, if x and y are both function of the same independent variable t, that means you have x in terms of t and y in terms of t, these are called parametric equation and t is called the parameter. Okay, so we can differentiate parametric equation by using this formula. So as you can see here, this is very familiar. This is a chain rule. So we can differentiate parametric equation by using a chain rule. But here kita akan ada dt, okay, instead of du. Right, so let's go straight to example 23. So we have to find dy over dx in terms of t. So given to us x in terms of t, y in terms of t. So what you have to do here is basically just differentiate x with respect to t. So here we are going to get 6t square, and also differentiate y with respect to t. So we should have dy over dt equals to 8t. Okay, so now we want to find the first derivative. We just substitute into our parametric equation or chain rule. So dy over, sorry, here is dy over dx. So the formula should be dy over dt multiplied by dt over dx. So here dy over dt, straight away we have 8t. So just substitute 8t here. But be careful here, this is dt over dx. What you have here is dx over dt. So what are we going to do is just terbalikkan 60 square ni akan jadi 1 over 60 square. So here should have 1 over 60 square. Okay, now we can just simplify 8 divided by 6. We have 4 over 3t. Okay, so that is your answer for dy over dx. Okay, so let's try one more question here. We have x equals to 3 over t and y equals to square root 1 plus t square. So basically this is just a basic differentiation. Okay, just differentiate x with respect to t. You should have, so this is 3t negative 1. Okay, so power pindah depan negative 3, power tolak 1, we should have minus 2, and then we simplify negative 3t square. Okay, now we want to differentiate y with respect to t. Okay, we can simplify this as 1 plus t square power 1 over 2. So differentiate y with respect to t. Power rule ada 4 step. Okay, please don't forget this. Power pindah depan, salin balik, power tolak 1, differentiate dalam. Okay, so that's the 4 steps to differentiate by using power rule. Okay, so make sure by now kamu dah boleh buat lah benda ni. So we can simplify this. We should have t over square root 1 plus t square. Alright, so now we are going to just substitute into our chain rule. Dy over dx is equals to dy over dt multiplied by dt over dx. So our dy over dt is this one here. So we have t over square root 1 plus t square, and our dt over dx, this is our dx over dt, therefore our dt over dx kita kena terbalikkan lah. So that should get us t square over negative 3. Okay, kita tak dalam bracket lah, negative t square over 3. So now we can just simplify. We should have negative t cube over 3 square root 1 plus t square. Alright, okay, so that is your answer. Okay, so let's do one more question here. Okay, yang ni saya rasa kamu boleh buat sendiri. Example 24, you can try it by yourself. Okay, so it's okay. Kita try lah. Find the value of dy dx if x equals to t minus 1 over t and y equals to 2t plus 4 over t when t is equals to 2. Okay, so given to us here t is equals to 2. So your final answer should be a value. Okay, so now just macam biasa, kita differentiate x with respect to t. So this is our x. So we should have 1 plus 1 over t square. Okay, so by now you should know lah, ini ialah t negative 1. So we should get negative 2, negative t power negative 2. So samalah dengan ini. And then our dy over dt, differentiate y with respect to t. So here we should have 2 4 over t. So that means we have negative 4 t negative 2. Right, so that should be negative 4 over t square. Right, so minus 4 over t square. So we have our dx over dt and we have our dy over dt. Now just substitute into our formula. Dy over dx is equals to dy over dt multiplied by dt over dx. So dy over dt is 2 minus 4 over t square. And our dx over dt, dt over dx, kena terbalikkan lah. So, bila terbalikkan, kalau nak senang, if you get this, some expression macam ni, kalau nak senang, kita samakan denominator dia siap-siap. Okay, samakan denominator dia. So, here you should get t square plus 1 over t square. Okay, so this dengan this are the same thing. Okay, so bila kita nak cari dt over dx, we just have to terbalikkan je lah. So we have t square over t square plus 1. Alright, so now it's easier for you to simplify. Okay, ini pun kita boleh samakan denominator kita. So we should have 2t square minus 4 over t square over t square plus 1. Okay, so we can cancel t square, then the final answer is 2t square minus 4 over t square plus 1. Okay, so if you want to simplify your fraction, if you have something like this, you know what to do. Okay, just samakan the denominator. Okay, but remember the question said find dy over dx when t is equals to 2. Okay, so we are going to substitute when t is equals to 2, dy over dx is equals to 2 square minus 4 over 2 square plus 1. That should get us 4 over 5. Alright, so now example 25, you can do it by yourself. Okay, differentiate trigo dekat situ. Make sure you know how to differentiate your trigo. So the answer here is dy over dx is equals to 4 cos 3t. Okay, please try. Okay. Alright, so now let's take a look at question the second derivative of parametric equation. Okay, so second derivative of parametric equation. So as I said earlier, you have to know this formula here. Okay, so just hafal lah formula ni. As you can see, we have second derivative d2y over dx square. The numerator is d over dt, dy over dx. What does it mean? Simply just simply differentiate dy over dx. Okay, sorry, tersasul-sasul pula. Yang numerator ni we just simply differentiate dy over dx. Yang denominator basically dx over dt, what we have already find here. Okay, this one here. So now let's see example 26. We have x equals to 2 over 1 minus t square. We have y equals to t over 1 minus t. So the first thing first, you know that if you want to find the first derivative, we have to differentiate x with respect to t, and we have to differentiate y with respect to t. So this one here, how are we going to differentiate this? By turning this into power rule. Okay, we can use power rule, or if you want to use quotient rule, that's fine, boleh juga, tak ada masalah. This one you can use quotient rule. Okay, so the first question here show that this one basically we just want to find dy over dx. So let's differentiate x with respect to t first. So dx over dt. So here is the function, power rule, 4 steps. So the first one is power pindah depan, salin balik, power minus 1, differentiate dalam. Okay, differentiate 1 minus t, you should get negative 1. Okay, so now simplify, we have 4 over 1 minus t cube. Okay, now we are going to differentiate y with respect to t. So you know that you can use quotient rule there. So u is equals to t, u prime equals to 1, v equals to 1 minus t, v prime equals to negative 1. So by using quotient rule, dy over dt is equals to 1 minus t times 1 minus t times negative 1 over v square. So 1 minus t square. So simplify yang atas, we should get 1 plus 1, we get 2. Betul ke ni? Negative t plus t, we get 0. 1 plus 1, that should get us 2. Betul tak? Oh, sorry, 1. Sorry, 1. Okay, 1 over sini. Okay, betul lah. Sorry lah. Dah malam. 1 minus t square. Alright, so now we just substitute into the formula. dy over dx. Saya tulis sini lah. So to find dy over dx, we just substitute into our formula or our chain rule, dy over dt multiply by dt over dx. So our dy over dt is 4 over 1 minus t cube. dt over dx, sorry, terbalik. So dy over dt is 1 over 1 minus t square. dt over dx is this one here, but terbalik. So that should get us 1 minus t cube over 4. So final answer, you can simplify here and here. That should get us 1 over 4 1 minus t. Itulah dia. So this is the same like this one. So shown lah. Okay, so that is the first part. Sorry, ini dekat atas. Okay, 1 minus t ni dekat atas. 1 over 4 1 minus t. Okay, so that is the first part, which is we have to find dy over dx, the first derivative. And then now let's take a look at the second question, where the question asks us to find second derivative. So as I said earlier, we just have to use this formula. Okay, bukan kita ambil ni. Ingat, kamu tak boleh differentiatekan sekali lagi. Okay, remember this is your dy over dx. Okay, to find second derivative, tak boleh terus differentiatekan ini, sebab this is dy over dx. Sekarang this thing here is in terms of t. That's why you have to use this formula here. Okay, so this formula, what you have to do is basically the first part, the numerator, you just have to differentiate this with respect to with respect to t. So here is the formula. So d2y over dx square is equals to d over dt dy over dx. Okay, just basically just differentiate dy over dx with respect to t. So below here is dx over dt. Okay, so let's do this. So d over dt. So what is our dy over dx? So our dy over dx is basically this thing here. So 1 over 1 minus t. Okay, so now over dx over dt. So dx over dt, where is our dx over dt? Here is dx over dt. Okay, tak perlu terbalikkan because the formula here want dx over dt. So this We transfer here. 4 over 1 minus t cube. Okay, so now we just have to differentiate this with respect to t. So this one you can differentiate because the formula said with respect to t. So here we should have 1 over 4. Here differentiate, we get negative 1. So that should get us negative 1 over 4. Negative 1 over 4. Okay, yang bawah tak payah risau, biarkan sahaja. Sebab kita tak perlu differentiatekan apa-apa. Okay, so now just simplifykan. We should have negative 1 over 4 multiplied by 1 minus t cube over 4. That should get us negative 1 over 16 1 minus t cube. Okay, so that is your answer for your second derivative. Alright, so let's see example 27. Okay, example 27, you can try it by yourself. So dy over dx is negative 60 cube, and second derivative is 18t4. Okay, here, this is the last question that we are going to discuss. So example 20x plot 28. If x is equals to t e to t and y is equals e to t, find first derivative and second derivative when t is equals to 0. Okay, so first derivative basically just chain rule. Okay, so you have to find x with respect to t, you have to differentiate y with respect to t. Okay, so dx over dt. How are we going to differentiate this? Satu function. Okay, there are two functions. One function multiplied by the other function, so you have to use product rule. Okay, so you have u is equals to t, u prime is equals to 1, v equals to e to t, v prime is equals to 2e to t. Saya harap kamu boleh lah basic rules, tak perlu saya terangkan banyak kali. So we differentiate dx with respect to t by using product rule. Should get us e to t plus 2t e to t. Banyak betul t. Alright, now we are going to find dy over dt. So this is easy, dy over dt. Our dy over dt is basically 2e to t. Okay, so now we are going to sub into our formula or our chain rule. So dy over dt multiplied by dt over dx. So dy over dt is 2e to t, dt over dx, all of this terbalikkan. That means 1 over e to t plus 2t e to t. Okay. So now we can simplify. So this part here we can factorize e to t. Kita tulis macam ni lah, senang sikit nampak. Equals to 2e to t over e to t. So factorize this part here, we should have 1 plus 2t. Okay, so now we can simplify. This one we can cancel, and the answer here is 2 over 1 plus 2t. Okay, so now we are going to find our second derivative. Okay, so by using the formula. Okay, the formula for second derivative. So here we have the formula for second derivative. Differentiate your dy over dx with respect to t over dx over dt. Okay, so d over dt. So what is our dy over dx? So this is our dy over dx, or to make it easier, tak nak guna quotient rule lah sebab kita ada constant dekat sini kan. We can simplify this to 2, 1 plus 2t negative 1, which is we can use power rule. So here we should have 2, 1 plus 2t negative 1. So our dx over dt is basically this here. Okay, so over e to t plus 2t e to t. Okay, So now we are going to differentiate this part with respect to t. So by using power rule, power ke depan, salin balik, power tolak 1, differentiate yang dalam. Okay, yang di bawah salin je balik. E to t, or we can actually factorize. Here we should have 1 plus 2t. Alright. Okay. So atas kita akan dapat negative 4. And we can simplify this here, negative 4 over e to t. So bawa turun 1 plus 2t, so that should be power 3. So that is your second derivative. Okay, but remember the question said when t is equals to 0, that means you have to find your dy over dx when t equals to 0. So you have to substitute your t here and also here. Okay, so when t is equals to 0, boleh buat sendirilah untuk dy over dx tu. Negative 4 over e0, 1 plus 0 cube. And that is negative 4. Okay, so that is how you use parametric equation. Basically, just use the formula to find first derivative. Use the first rule, the chain rule, to find the second derivative. Just this formula. Inilah yang maybe kamu kena hafal sikit lah. Alright, so for exit ticket 27. Okay, 27 betul tak? Yes, exit ticket 27. This is the question here. Okay, so this is going to be your exit ticket 27. Make sure to submit this on GC, and that is all. Thank you guys.